So, good afternoon. You're welcome. Today is our first class, and we're talking about data science. And as we discussed, during the orientation, this is a very important field, especially in the world of today, when everything is going AI. So the secret behind it is data. So, in this training, our hope is that you will be guided, to be introduced to the core tools, core principles guiding the field. And so the course outline will be shared for those who register, but today we'll begin with just with basic concepts, introduction to data science, and they will focus more on key terminologies that we'll be using, some of them. There's still many that we'll get in a few classes. So now, for today, we will be more theoretical, but it is important for us to understand that this is a practical training. Yes, this training is practical. And so to succeed in this training, you need to have a laptop, a good one if possible. And if you are online, you need to have good internet to get the best out of the training. Now, there are different applications that we'll use, as we indicated. We'll use one of the major applications we'll use, which is highly utilized in the world of data science, is Python. So we'll see Python and its various libraries. We'll see SQL, we'll see database. For database, we'll talk about Power BI. We'll also see SPSS, and we'll equally use Excel. For Excel, we may not go into deep. We'll just be using it maybe lightly. But the other applications we'll do our best to see. So you're all welcome. So before we continue, let's pray. Heavenly Father, King of Glory, we thank you for this session of the training. Pray that, Father, you guide us, direct us, instruct us, and help us that the objective why we are here will be achieved. Father, thank you as we pray in Jesus' name. Amen. Okay. So there are some key concepts that we'll see. So in this training, we'll discuss. We assume that everybody is novel. There are some people who have already been taking this course. They have some foundational knowledge, but we are assuming that everybody is new. And so there will be no assumptions as to maybe whether you already know some of these terminologies. We'll revisit them because we believe that they're quite useful to succeed in this field. And we'll talk about it. Like I said, by next week, we'll share our course outline so that we have a structured approach of what we'll cover. And that will be when, only for those who would have officially, there's some people who are not yet official students, that will be done. So today we'll start discussing the first concepts that we'll see. We'll start with the concept of data. If I talk about data analysis or data science, it is important for us to start from the foundation. And one of the first concepts that we'll be discussing is data. We'll discuss what data is, and we'll differentiate it from information. Then we'll go on to talk about the different disciplines. I know we discussed some of these things, but we'll still revisit them. We'll see concepts like variables, levels of measurement, the data science life cycle, what it means when you're working as data scientist, the application of data science, and many others. So that's what we basically will be covering. So to begin with discussing data, anybody with a different definition to data, or you have a definition of what data is? Again, I always like that it should be interactive. For the notes, you can get it thereafter. Just follow. You should get it thereafter. Especially if you're in the group, they would have shared it there. I think so. Unless you're not in the group. So anybody who can give us a definition for what data is, online, offline? Anybody? Nobody. Okay. As you see from the slide, we say data refers to raw facts that have no specific meaning. Again, that definition we said last time that think of data as anything that happens repeatedly. Yes. Anything that happens that have a pattern, even if there is no pattern, but that we can study it. For instance, if you go online and you're watching movies, you're generating data. So you say that there are raw facts. The idea behind the word raw there simply means while we have these facts, we haven't analyzed to get meaning from them. Give an example of the number of messages you send out, either through friends or to whatsoever. That's data. But we may not be able to make meaning from the messages until we start analyzing the content. So when we start analyzing the content, we'll discover that we send what kind of messages more often. We may not know who are the customers to a business. We're just selling. But when we start analyzing, we'll discover that we have customers with some unique attributes, maybe in terms of their gender, in terms of age, in terms of education, in terms of geographical location, in terms of their income level, and so many others. It's only when we start looking at that data keenly that we are able to. And we said the only reason why you want to collect data analysis is because that data gives you the possibility to make informed decisions. And so the only reason companies collect data, analyze data, or even individuals is because they want to make decisions. And their desire or the ultimate goal is that at the end of that discussion, at the end of the analysis, and their decisions should help them to get better. A company may want to look for ways to minimize costs. They may want to look for ways to optimize profits. They may want to look for a way to optimize operations. For instance, there are systems that are repeated. They may want to automate. Even in the world of data science, there is a system that you automate so you don't have to do them over and over. You can build an application in such a way that whenever you receive new data, you just refresh. So you don't have to go through that constant cleaning. And so data gives organizations, gives companies, NGOs, government, the latitude to take decisions based on facts. That's the essence of data. And because of this, we analyze data. When we analyze data, we now derive from it what we call information. So information emerges from data. So we could say that the reason why we analyze data is because we want to get information. So information, basically put, it is processed data. When we process our data, and that process could be looked upon as analyzing, we get what we call information. So that information now informs the decision makers on what should be do. What is the optimal decision? What will be a poor decision? What will be an ideal decision? Because they're working with facts. Any question? Anywhere else I'm going, please, offline, online, just stop me and ask your question. Because you may have a challenge or hear something you want me to repeat. then just indicate and ask your question. So in terms of definition or the origin of the word, you see that they say data comes from the Latin word Latin, which means something that is given. Like we said, it doesn't have any meaning. And so we just give it and you just collect, for instance, we go to most of hospitals, they collect a lot of data. You go to take your vital signs and the rest, and at the end of the day, the doctor may look through and say recommend some. But if we have to collect the vital signs and we have been doing that for maybe the last 1 year, and we come and we study that data, we'll see that this is a common disease. These are the type of people that this, and we can optimize the way healthcare is delivered. It's just about optimizing decision making. And so we basically, there is this obsession in all of today for data, because competition today is not only that you have the best workers, competition is today is not that you have the best or you have a lot of money. Competition is who can serve the customers at the right time with the right solutions, and that they should be what? A war experience. And so there is that constant competition, everybody. And with AI, the competition is getting more tense, it's fierce, it gets fierce every day, right? And so MTN sits and they're worried how they can get better. They may find challenges. You may think that MTN is not conscious of the fact that we're struggling to. There may be limitations, but they keep studying. They have data analysts there, they're studying, who try every way possible to optimize the different user experiences so that they can make more money. And so once we analyze our data, we get the needful information. And that's what is important. That's what is important. So the information that we get from data helps us in decision making. So having understand the concept of data. Now, what is data science? Now, from saying that data is raw facts, then data science helps us to analyze. So data science is a process that helps us to collect data, analyze the data, we collect, we clean, we analyze the data so that we can get the needful information. So it's a process. Unlike we say data, which is maybe what we haven't analyzed, but data science is a process. And so understand data science from this dimension. It is a combination of science and art. Data science comes back with this. I think data science is more arts inclined than even sciences, in that it needs a lot of creativity. When you're working at data science, you need to be creative. You need to, because for you to really achieve the best results, you need a certain level of creativity. So it's a combination of arts. It's about storytelling. You want to tell a story. When you collect data and you're analyzing the data, the only reason why you're trying to analyze is to tell a story. And somebody listens to a story. A person doesn't need to be a data scientist, doesn't need to understand all the statistics that you know, but the person should be able to have an understanding. And so it is a blend of creativity and scientific tools for decision making. So, in other words, we could say that data science is a combination of different fields. As we see, it's a combination of different fields. Now, somebody is asking if data science is the same as data analysis. Who can answer the question? Is data science the same as data analysis? You should be talking now. People are quiet. It's like we're in a strange land. Yes, give it.
Yeah, I think data analysis is a subset of data science.
Okay, she said data analysis is a subset of data science. Okay. Any other definition? Now, like she said, data science, at times these concepts are used interchangeably. But if you want to become more meticulous, you'll see that there's a slight differences between them. For instance, a data analyst most often may not have all the skills that a data scientist will have. You can be using maybe even without a programming knowledge, you can still call yourself a data scientist. I mean, a data analyst, right? For instance, you're using only Excel, you're using SPSS, so you can still be a data analyst. But for you to call yourself a data scientist, I think it's mandatory for you to have programming skills. You need to have at least some basic programming skills. You need to be able to use, because you should be able to collect data, clean the data, analyze the data, and build data science models, build algorithms, as we will see. For instance, you want to build a machine learning algorithm on predicting whether a customer will pay or will not pay, or how much a customer can pay. So that next time, or whether a customer in a bank will be able to pay back a loan or not pay. Those are possibilities. And it's very common with data scientists, unlike with data analysts. It doesn't mean that somebody as a data analyst may not, but that data scientists may need more skills, more tools to ensure. We'll talk about big data. Data analysts, I think, or data scientists, I think, about big data. Big data, understand big data as data that is too big to be used in a single computer. For instance, think of Google. The data center that Google has thousands of computers to be able to process. I think even where it can be small for the data science center that Google has with that is mainframe computers, not small laptops like this. So they're able to. So there is that skill set that we expect. You should be good with programming, you should be good with SQL, you should be good with to really consider yourself as a data scientist. So, but then we often use them interchangeably. Now, like I said, data science extract meaning from data using scientific methods. That's why we say there's a creative part. But what is important for us to note is that it uses scientific methods. For instance, when in research, if you get up and you face a challenge and you solve it, that is not considered research, right? You must go through that process of problem definition, data collection, analysis, interpretation of the results, conclusion, and recommendation for issue to be considered scientific research. At least you must define so that you collect the data, you analyze using so because it only becomes research when you use scientific methods. And so even with data science, we are using scientific methods. You need to, for instance, to analyze your data, it is expected that the data should be clean. If your data is not clean and you analyze and draw conclusions, they may be wonderful, but the results are not valid because you did not follow that scientific procedures. So there are scientific procedures put in place. They use scientific algorithms to be able to make decisions. So data science helps us to turn raw data into actionable knowledge, which means it's knowledge we can use to make decisions. That's the essence of data science, that we are able to make decisions. And so I always say that look at it from this perspective. You're a detective looking for information from the data, which is the process of analyzing. So you are able to do what to solve any issue. That is how data works. You are a data science gives the data scientist the skills, the tools, and to be able to detect issues in data or to extract meaning in data so that we can make informed decisions. That is the point. So, again, data science is the interplay of different skill sets. This is the interplay, or we have different skill sets that makes you a data scientist. Principal, we have three skill sets that are vital: computer science, mathematics and statistics, and then domain knowledge. I think in our orientation, somebody was like, if you are, and I remember somebody even asked me, if you go to university or to school and you specialize in data science, how do you now have the domain experience? Again, even if you go to university and you work as a data scientist, for you to be successful, you go to a company, right? Unless it's a data science company, even if it's a data science company, they will still have a way that they operate. You will still need to understand the domain, because data science company must necessarily work in a particular domain, or what if they work in multiple domains, still need to have understanding of the field. If you give me the bank data, I might try to analyze the data, but the truth is that I might not get much from the data because I don't understand how the bank operates or the banking sector operates. I don't know what it takes to grant a loan. I don't know what it takes to, I don't know this and that. But once you have that understanding, that domain knowledge, you get data, the information just naturally flows. So the computer science and IT aspect talks about the ability to do programming, to be able to program. Computer science talks about programming. It's not necessarily having advanced programming. Now, somebody says you're a data scientist, then you know a bit of programming, but not as a programmer, right? Yes. You know a bit of statistics, not as a statistician. And then you can now apply these concepts in solving problems. That's the idea. So you need computer science knowledge, which we say will be programming, and we've indicated machine learning. Now, machine learning is a field on its own. Although when you hear machine learning is about teaching computers to behave like human beings. Now, what is the central thing when it comes to machine learning? It's about algorithms. You are building algorithms. You train, you test, and you deploy. You train, you test, and you deploy. What do you mean by train, test, and deploy? For instance, let's give a simple example, which we said. If you go to the bank, and as a data scientist, you have to work with a loan officer. So you meet a loan officer and you tell the loan officer, sir, we want to automate the loan process. And how are we going to do it? Say, okay, since we have been giving loan for the past 5 years, right? Let's go to the database and retrieve this data. Once we retrieve the data, we'll analyze all what it takes to give a loan. For instance, when you get to a loan for somebody who have gone to the bank, they will ask for your profession, they will ask for your income, they will ask for people that depend on you, they ask for maybe source of income, they will ask for maybe next of this, the purpose of the loan, all of that. And this information is used to determine whether they will give you a loan or not give you a loan, right? Now, once we collect that information, we go back and say, okay, for the past 5 years, we collected this information. Did some people default? Yes. How many people defaulted? Maybe about 30%, right? And so the way you build a machine learning algorithm is that you will take those who did not default and those who defaulted and teach the computer to study. They will study and see the patterns that repeat themselves in those who defaulted, the patterns that repeat themselves in those who did not default, so that we know exactly who has the high probability of defaulting, right? Now, once we train this, when we get to machine learning, you understand the application. This is what we call test train. For instance, we take all the data and we segment. This one normally happens. We take all the data, we take 70% or 80% of it and do training. Training means study all these data sets to identify who defaulted and who did not default. Now we test if after we have done the training, we come and test for accuracy and see the ability for it. For instance, somebody defaulted. Is our application or our software able to predict that this person defaulted? We know that this person defaulted, right? We also ask the machine to see if the machine will determine whether this person defaulted. We know that this person did not default. If the machine is able to identify this person did not default. So we'll see there is a quadrant of decision making, but that is training the computer to be able to predict, to see somebody and know this person is highly likely to default. Once we have a good accuracy rate, for instance, maybe 90%, that out of maybe 100 persons, we may make mistakes with 10, but at least we get it right with 90. We are able to deploy that model such that when somebody comes now and apply for a loan, what we basically do is that we take the person's information and put it in the software, and the software says this person will pay back the loan. or this person will default the loan. That will help us to automate the loan process such that it doesn't have to take 2 weeks to vet a loan. Machines automatically says this person has high probability of paying back the loan. So we grant the person the loan, or the person may not pay back the loan. Now, once the machine gives, we can go ahead to do other due diligence to see whether we should still go ahead, right? But that early vetting is vital. That's automating the loan process. That's the aspect how machine learning function. We'll see that. Now, another skill is data visualization and storytelling, or data processing and visualization. Now, this is actually data analysis. You should be able to process data. Processing data has to do with exploring, cleaning, and making sure that data is ready for analysis. Then visualization is, for instance, instead of just presenting what we have presented, we use charts. We can use a chart like this. This is what? A pie chart to present our information. So that it's much more explicit. I could have explained just in text, but I decided to use charts. That's data visualization. So those are the core skills that you need to succeed as a data analyst. So in each of these different domains, there are certain tools that will be used. For instance, data visualization, we will be using Power BI. We'll go to when we'll use even Python, we'll be able to use libraries like Seaborn, Matplot, and many others. We'll see how that is done. Computer science, we'll say, okay, we'll go with what? We'll use Python, which is a programming language. It helps us to program. It's a programming language used by programmers to develop applications for scripting, but also used by data scientists for their work. Apart from Python, we have R, but we will not use R during our training. R is just one. There are so many others, and every day new ones are coming up, right? But we'll choose to go with Python because it's the most used. And one of the reasons it's most used, it has a lot of community. There are so many people that are using it for different things. So when you have a challenge, you can easily have a solution to it compared to others. And much more, it is the main application that is used in the world of AI and machine learning. So it gives us that possibility. So we'll see that. Then we'll talk about mathematics and statistics. We'll be able to understand all the different descriptive statistics. We'll talk a bit about algebra. Now, we'll try to not go into the hardcore mathematics in order not to scare us away, right? But we'll try to present the concept in a very simple way for you to understand, even if you have some phobia for maths or statistics and probability. We'll try to present, for instance, what is a vector. We'll see what a vector is. A vector is just like a list. I imagine that a vector is just like your market list. You want to go to a market, you say, okay, I need to buy, you may come out with a list for fruits that you buy. I have to buy mango, I have to buy pawpaw, I have to buy this. That's the list, right? You may also bring in another list. For instance, cooking things that you need, this and that. So you have two lists. Those two lists now form what we call a matrix. So we'll try as much as possible to present these concepts in a very simple, dynamic way for us to understand. But again, as a data scientist, you have to work hard and learn and go extra mile. You can't limit yourself because no matter how we give, we'll just give a bit of what you need to know. We have a lot. And remember, this is a program that people take years to. In some university, it takes about 4 years, some take 2 years, and this and that. And so we will be compressing it. So that's why we may not go into the hardcore mathematics and the rest. But again, in the world of today, you don't necessarily need to know the hardcore mathematics, but you should at least know when to use a tool, right? And how to interpret your results when you get it and when you can use it, because AI may help you do a lot of things, but then you must know the right thing. Otherwise, it will give you wrong results. So again, another field that is important or that data scientists across is research methodology. We talk about research for those who are from the academic setting. We say, okay, chapter 1 talks about introduction and problem objectives. We have to review what others have done. We have to talk about methodology, which is collecting data and how you analyze your data. You have to analyze. So that's where, data science borrows from the knowledge of research. The scientific procedures that we mentioned are borrowed from research methodology in their decision making. Any question? Any challenge? No question? Yes. Okay, for domain and business expert, I think, like we said, if you are studying data science and you come from, you say you did logistics in school. So when you want to apply it, you apply it better when you are working in the logistic field, right? For instance, there is what we call the last mile delivery. How can you optimize the last mile delivery using data? How can I make sure that, for instance, let's say you're working with a company that is maybe an online store. They have centers in Yaoundé, Bamenda, this and that. So for you to optimize, you want to make sure that when a customer gives an order, for instance, you give an order, right? You build an algorithm in such a way that the system decides where you should be set. So they need to study where you are with respect to the nearest store or the nearest warehouse. And your product is picked up from there to give. Because if I wanted to pick, if you are in Buea, and I want to say, okay, because I place the order and wait, but Yaoundé should deliver, what happens? The cost of delivery will be high, right? But with algorithm now and with the analysis, you say, okay, when this order comes in, we check to see which will be the most cost-efficient way of serving you and say, okay, since you are in Limbe, Buea should supply you. And so the system automatically indicates to Buea that, okay, an order has come or they came from Yaoundé, deliver to this person in Buea. So that is applying logistics to optimize the last mile delivery method. Or you want to be able to I'm not an expert, but then the concepts, the principles in your field, you adapt data science into it in solving problems in that field, because each field has its own peculiarities. A field has something that is unique. If you were working in an NGO as an example, and so most often you have to analyze data to see maybe they want to distribute things. You have to analyze who are those who are likely to benefit because they have this challenge, right? How many of them are there? What are their preferences and so on and so forth? How can we go optimize the data, even the data collection process to make sure that we collect data from the right people and that we give products to the what it has to do with collecting data, analyzing it, and making sure that the systems are more efficient in whatever domain you're doing. That's what data science seeks to achieve, regardless of which industry. Elon Musk wants to send rockets to Mars. They will need to look for the most efficient ways to do that. They need data. And if they send and it fails, they have to come back and calculate and analyze and see what went wrong and how can we improve on that. And with data science, the more data you have, the better your results. That's why for those who have used AI like ChatGPT, when ChatGPT came up, it was like, wow. But then there were so many issues. If you want to use ChatGPT now, it's more efficient than one was because for these 2 years, there has been significant improvement. People have been trying to use it, and the more they use it, the more it learns and improve its functionality or this and that. So that's why they are getting better and better and better every blessed day, because people keep giving them different challenges, this and that. They get it wrong, they say this and that, this is the right thing, and so on and so forth. So the more data you have, the better your results in real world. The obsession with data is simple. Data makes you become more efficient in achieving your objectives. That's all. Whether as a company or as an individual or maybe profit or non-profit and take, non-take, whatever field. Those who have used data, they are all constantly outperform those who are just operating by experience and guess, right? Because they have facts, they know when to. There is somebody who is selling. He's using the data at a very small level, but what happens is that he started, whenever he goes to the market, he sells, he comes back, he records. He sells in the market, actually, sells shoes. And so he did his data analysis. I think he's among those, the first people that learned data analysis. We were still focusing more on using SPSS around 2019 or so. And so when he learned, he started applying. I think he's in one of those pictures there. He started applying the concepts and the principle. And what happens is that he was just doing by normal Excel. Whenever he comes back to the market, he will record what he went and how the sales for the day and so on and so forth. After some time, he started predicting such that he knows when to stock more. Especially before Ramtres score, he knows exact type of shoes to go and buy. So before people think that we should go and buy, he already knows the market. He buys, so like people come and see from him that, oh, this is, he often gets the products before time, before people even think that this is the time that they should buy. So he has studied the market. He knows, that's why we call it seasonalities. Seasonality means there are some moments that things have to. And it's not that you just go and buy. He knows the quantity to buy because it's better if I buy like this before it goes through. So he started studying, collecting the data, and it makes him to always like, people are like, why are you always, he always seems to be the first because he knows when to place an order, when you will arrive, not just by estimating, but the data keeps telling him. So he tries to optimize. So that's how data works in every field, small business. As you're selling, you know that during this period, buy this particular brand of shoe, right? Yes, and you can estimate what quantity to buy. So before people discover, because it's, hey, this one now you need the pass. He is not buying because people are now, he already know that this is what will be happening at this particular hour or at this particular time, right? Yes, not guessing. Again, data supplement what we know and give us the opportunity to optimize what we know. It's not like you, if you are selling on your own, you are now using data, you will not know that maybe you may sell this. But that data gives you more reliable information and can give you specific time. For instance, on Tuesday, you should cook this quantity of food, right? This type of food and this quantity. On Wednesday, cook this type of food and this quantity. It's not like that you just cook, right? If you start analyzing, you discover that, for instance, there are some people, they start selling by 1 o'clock, their food is finished. And people come and there's no food. People come and there's no food. It has been happening like that. But if you're analyzing and using data, you know that maybe if my food is ending by 1 o'clock, I can add this quantity to end by 5, right? So that people don't come. You know the quantity that will extend up to 5. So it's not, data science is not something that is too utopic. It's real. You can use it at a macro level, you use it at micro level, even an individual level. So you are on whatever you are doing because it seeks to identify patterns and anomalies. So anything that has a pattern, data science says, okay, this happens like this happens like this happens like this is how often it happens, this is how often it happens. And so expect that the next will be like this. Where you see that maybe people are predicting that it will rain on this particular time, this and that, because there's a pattern. They use data to determine that it will rain tomorrow 5 p.m., right? And this will be the severity of the rain, or it will not be severe. Stay at home, go out, and especially in these polar regions that have a lot of issues with weather. So they're so conscious and they'll know exactly when it will rain, the intensity of the rain that will fall, right? And the necessity for precaution or measures to. So those are some issues that data science has to do. Like I said, it only gets when you have that domain knowledge to do it better. Any question again? Please, let's try to ask questions and be interactive. It's very, very important. So, what are the core components of data science? The core dimensions that a data scientist will need to take into account or understand is data collection. But I always say that before you even talk about data collection, we start with problem definition. You need to know what is at stake. We talk about the last mile challenge, right? The last mile challenge is, for those who have done logistics, they will understand last mile challenge, one of the major challenges organizations face when they have to do with, especially retail. For instance, you buy something in China, the thing is very cheap, but because you have to deliver in Cameroon, it becomes very costly. Yes. Something for China, maybe 1,000 francs, in Cameroon, 10,000, because of that transportation cost. So it is a big problem that any organization that into the logistics sector keeps looking for ways to optimize it. Or you're in a bank, you have to give loans. You know that the greater part of banks' money or revenue or whatever they make profits comes from the giving of loans. But they also want to give loans and people don't pay back. So how do you minimize the issue of not making losses from your loans? That you should be able to minimize losses as much as possible. So it becomes a concern for you, the person working in this area. And so how do you solve that problem? As a bank manager, I was working, there's one guy who took data analysis here. Again, he used to work with, was it Unix? I don't know where you need one, but one microfinance. So he said one of the major challenges they face is the ability to collect loans, collect back loans from clients. A client come and collect loans and disappear. So they keep looking for ways to make sure that they're able to give loans and collect the money. You don't also want to store all the money with you, right? You don't want to keep everything. You want to be able to. And so if you don't, if you don't give out loans, you will not be profitable. You will go out of business. You will not be able to meet your operating costs. But there's a risk of giving out loans. So an organization that understands this will look for ways. So if they hire you as a data scientist, what's your objective? To make sure that you minimize the default rate as much as possible. You can't eliminate it, but you need to minimize it. If they were having maybe a default rate of 30% and you bring it to 50% or 15%, you would have saved the organization lots and lots of money. That's your work as a data scientist, to help minimize losses by just simply automating the process and making sure that you analyze and have what we call personnel, which is the profiles of potential clients. You understand your clients very, very well. In the bank, they talk about KYC, know your customer. You help the bank to understand their customers and know them very well, their needs. You get that? So that is one of the issues that you have to take into account. That's problem definition. Once you have defined the problem, you need to collect data. And data collection asks the question, yes, with this problem that I have, how can I get data for this problem? Right? So you need to decide where to collect data. Now, we'll talk about data being structured and unstructured, right? We'll talk about data being primary and secondary. Primary data means you are the person collecting the data for your own use. The loan officer is collecting data before the person grants you loan because the person wants to use the data. But then, apart from the loan officer using the data, you can go and take the data as a data scientist. So it's secondary data to you. You are collecting existing data to come and analyze it to solve another problem. You are not the primary collector. So you become secondary data to you. Or you go and take the financial statement of a company and you analyze them. Those are secondary data. You go to archives or the National Institute of Statistics and collect data about the different social or different issues in Cameroon, like the GDPs, the gross domestic product, which they say, or the foreign direct investments that are coming in, remittances, and the rest. That's secondary data. And so once you collect this data, you analyze it for whatever. So, but before you know which data to collect, you must know the problem that it is. You can collect data from databases with purification of softwares. Now, every organization is using a software for whatever purpose, is collecting data. So you go and retrieve that data from that software, right? So you need to have access to the database, whether it's SQL or whatever database they're using. You need to have access to that and retrieve the data and use. So one of the skills a data scientist needs is the ability to collect data. And you can either collect data from existing systems or you issue a new instrument, you develop a new instrument. So you need to have the ability to design a questionnaire that can collect the data you need for your work. So instrument design is a core skill that you need. You can design it and deploy in terms of Google Forms, SurveyMonkey, Kobo Collect, and so many others. If you're working in the NGOs, you need to know how to use Kobo Collect and other related programs because they are very, very relevant in your ability. And if you are the technician, they always come back to you to design the instrument. You cannot be the technician and give the instrument to another person to do the design, right? Or even somebody designs the instrument to come for you to vet. For somebody, for instance, when students design their instrument, the supervisor go and meet a statistician to help you vet it. When they come, you are able to calculate, to check for reliability and validity and say, okay, the instrument is not valid. So we need to ensure that it's valid. It's not reliable. We need to change the question, change the wording, and make sure that our instrument should be able to get the information we want. You need to understand different types of reliability. Convergent or validity, we have convergent validity, discriminant validity, and so many others. And so your knowledge of that helps you as a data scientist. You are able to help the organization or to design the right instrument for this data collection. In sum, your data can be collected from primary source, which means you are the person collecting the data. The person here could be, it's not any, whether you are the data analyst or whosoever, data scientist, or anybody that's collecting data for the first time, you are the primary, that's primary data. And most often primary data is collected using questionnaires and interviews, focus group discussions, observation or checklists, and so on and so forth. You can collect those are tools that you use to collect data. Or you collect data from existing sources, National Archives, the company records, so on and so forth. So data collection is important. Once you have collected the data, the next important thing, which is where most of your work as a data scientist will be, is about data cleaning. We'll see what it means to clean data, the issues you need to check when you are doing data cleaning, and the approaches to clean data, and how to ensure that your data is clean and ready for analysis. Data cleaning, for instance, understand data cleaning simply as somebody who is trying to cook a meal. You don't just take your things and you have to do what? Prepare them, make them ready for right? And how do you prepare? You may need to say if it's huckleberry, you may need to ensure there are no leaves, there are no stones. You remove leaves, you remove whatever you think that needs to be removed, right? So same in the world of data, we have to do what? To extract those things that we think that are not relevant. For instance, missing data. How do we treat missing data? Duplicates, maybe a transaction will record it twice. So we cannot consider it as two different transactions. It's the same transaction. Or a customer come and paid money to a cashier, and accountant did not know. So when they recorded it again, so you need to do what? To remove that information. There are ways. Then after you have done the removing, you need to act. That's where you talk about transforming the data. You can transform the data. For instance, they give you the price, and they give you the price, the cost price, and they give you the quantity. But you need a total price to calculate profit, maybe total cost. So you can now create another new variable, which is total cost. You can create another variable, total total sales, so that you can get the difference between total sales and profit. So you can now come up with another variable, profit. That's what transforming, and you are still working on what? Data cleaning and processing. You want to process the data to be ready for consumption. So it's not only about cleaning, you also have to, it's not only about removing, you need to add. So adding new columns, adding new information. Maybe after you have analyzed, discovered that the information is not enough, you go back and collect and come and add. That's how the process works. Then data analysis. Once you have done with cleaning, you have to analyze the data. Analyzing the data means you run the necessary statistical tools or statistical techniques and see what you find. Our customer are mostly young ladies or young girls below 25. right? And so we know that our customers are those, and once we know that there are those below 25, we know some things that attract them where they are, right? Maybe they are mostly on TikTok. So we need to devise a marketing strategy that will meet them where they are on TikTok. Our customers are mostly those between 30 and 40. And so these are working class. Where are they? Most of them on LinkedIn. So instead of running our advert on Facebook, we go back to on LinkedIn. You understand that. That is the power of information. You have analyzed it and you now take a decision to solve a problem. Now, you can automate the process. That's where model building. Now, instead of doing this thing over and over again, we can build a model that will do it without us necessarily and teach a computer. That's where machine learning and all that comes in. That a computer should be able to do this without us doing it over and over. So you build a model. They should recommend which marketing, anytime you want to run a marketing campaign, because of the time, maybe it's on January, or this is January, and they tell you that, okay, because this is January, use by this marketing campaign. This April, use by this marketing campaign. This June or July, use by this marketing campaign. They are able to predict and recommend. And the more you use it, the more you have better results than just get up and choose anyone to use because you like. So it's not about what you like, it's what data is telling you. So that is what you build a model. When you go on Facebook or you're watching videos, it's not somebody who is sitting somewhere. It's a computer that's studying you and recommending you videos of the same videos that you like. But then they will ask you, do you like this video? You say yes. They'll bring you more of such videos. You say no, right? They will limit giving you the videos. So they're studying you and making suggestions. Same for Facebook and in many other businesses. Now, if you go into a business supermarket, what happens is that in big supermarkets, you think that things are just displayed. But there is a psychology to how things are displayed. And that psychology is informed by statistics. That certain things should be put in certain, maybe a certain corner of, right? Yes, because it helps in the way somebody perceives, and so on and so forth. So it is important. A/B testing. A/B testing is a principle it's in marketing and in data science, where you bring out two versions of the same thing and you study which one does better. So you want to run an ad, instead of running just one, you develop two different ads, maybe one with pictures and one with video. And you run the two ads at the same time, targeting the same population and see where they will go. That's A/B testing. You test, you see more, you upgrade, test and you upgrade, test and you upgrade. How do you conclude? It's data. Data informs you on that. Then communication and visualization. Communication simply means after you have done your analysis or you have built your model, you need to make your results available to the users. You're a technician, you're not a user. Maybe you have to present to CEO, you have to present to the clients, or you have to build a model and deploy it. Deploy means you make the model available in the production unit. Any question? So, in sum, these are different aspects. So you say, think of it as building a house. So each component plays a key role. The foundation is important. It doesn't mean that the roofing will not be important, right? Every aspect. Data collection or problem definition could be the foundation. The roofing could be the communication of your results. Every part is relevant. Every part has something to do, and that thing it has an important role in the process. So you may specialize in one, but you know that it is interwoven. There's some people who always specialize in analysis and visualization. There's people who specialize in modeling. There are people who specialize in data collection. There are people who are full stack, which means they do all. Any question? So I think what I've explained is already using, say, the CRIMS, which is cross-industry standard for data mining. Start from business understanding. I've already explained that. Collecting data, we have explained that. Once you collect your data, you should be able to prepare the data, you should be able to model the data, evaluate, and deploy. It's the same thing. The CRIMS approach. This is what I've been explained. Integrating the model into the business process. whether through automating system, reporting dashboard, or any other means. You monitor, you evaluate over time, and you make it. That's deployment. Concept of deployment. Before you deploy a model, you need to assess its performance quality, also known as accuracy. You want to know the accuracy of a model. Can I have good results over and over from this model? So that is vital before you do deployment. In data preparation, we've said that. So again, it's all what we are explaining boils down to what we call the data science life cycle. Data science life cycle. Go back to problem definition, data collection, data cleaning and preparation, data exploration, feature engineering. Now, the concept of feature engineering plays it this way. You may have 10,000 features that are highly likely to influence an outcome, right? For instance, let's say let's go back to the case of the loan officer we mentioned. If you are the loan officer and you collect information before you give out the loan, right? Do all the variables have the same weight? Maybe whether the person is employed or not is more important than the person's gender, right? Whether the person is maybe the person that ever defaulted is more important than the person just willing to. You need to. That's so feature engineering simply says that after you have built your model or you want to analyze and build your model, you build your model based on the most important features, most important characteristics. You will not go and put every little thing, right? You select maybe the top 10 features and you build your model. So it should be an efficient model. There are other features that may include, but they will not be that much relevant. So you go for the most important relevant features. Are we okay? Any question? We see also a model evaluation. I mentioned it earlier. How accurate is the model? That's a model evaluation. And we'll see things that are used. For instance, we talk about accuracy, we talk about F1 score, we talk about precision, sphericity, we'll see all of these things. But some of these things, we'll see them under machine learning. You want to evaluate the efficiency of your model so that when you are deploying the model, you know whether it's a good model or a bad model. Now, under machine learning, we'll talk about overfitting. Overfitting is where your data performs well when you are working with it in the lab, but when you get to the production center, it underperforms. Get back to the case of the get back to the case of the loan officer. The loan officers evaluate the accuracy of the model and the data science, they evaluate the accuracy and discover that it's 95%, which means that if we have 100 people that we are giving out loan, our model has the ability to correctly predict 95% of them, and 5% may be error. But you get to the real world, which was data that you had, you get to the real world, and it's predicting just 50%. So that would be overfitting model. We also have underfitting. A model underperforms when you are building it, but when you get to production center, it gets results, more accurate results. Those are issues treated under model evaluation. And there are tools to evaluate that, which we'll see as we make progress. Again, I don't think that we need to talk about application of data science in different sectors again. We took time to explain this during the orientation, but all sectors use data. All sectors generate data. So you can work in any sector. You can work in any sector. You just need to understand the basics basic fundamentals of the sector and a good grasp of your data science skills, able to go. So you can leave here and go and work in a bank, right? You may spend some time and understand how the banking sector, banking runs. Once you get that, you apply your data science skills and build adequate model. But if you are training in the banking sector and you learn data science, then you do better now, much more, and you find it easier because you have that domain knowledge. So that's how it works. Any question? No question. How about that? Today I'm doing a lot of talking. I do apply full standard application. Go take charge. I'm just talking and talking. It's all right. So when you've collected your data, before we even go into data collection, we've mentioned data collection. And we've explained the different sources like websites, social media, surveys, and questionnaires. We talk about even things like sensors, Internet of Things. Who knows the meaning of IoT or Internet of Things? This year. What do you mean by Internet of Things? Have you heard of it before? I remember. Abdul or Musa, what do you mean by Internet of Things, sir? Is he there? Okay. Nobody's talking. When we talk of Internet of Things, which is another new field that is growing, it is the interconnection of physical devices that communicate together or exchange information. For instance, a smart city is made, it's only smart if we have proper utilization of internet. For instance, maybe you have gates that or street lights and the rest communicating with the weather stations and so many days interlinked. Or in a home, a smart home where we have the gates open before you come, the gate opens just as you are approaching, right? Or your door opens, you can access your home when you are outside via web cameras and the rest. Those are what we call Internet of Things. It's a new domain that is growing. And so this domain also generates a lot of data. So you can also use sensors to collect data. You can improve road accidents if we are able to collect information in that domain. Then now, when you collect your data, it comes in principal two ways, although we'll break down as we make progress. It could be structured data or unstructured. Structured data is data that is presented in the form of rows and columns. So we have variables that are labeled, or what I would call labeled data, which is label. What label is more machine learning inclined. Labeled data on labeled data. And so with structured data, what happens is that it gives the data analyst, you collect your data, it could be in an Excel sheet where each row or each column represents a variable. It may not necessarily be an Excel sheet, it could be a CSV, which full meaning is command separated or delimited data. And so the idea is that the variables are well structured. You know which variable is this, which one is this, because it is well organized. That is as opposed to unstructured data. If we recorded this conversation and transcribe it, we will have unstructured data because we don't have direct patterns to what we're discussing, right? And that's where the natural language processing comes in now, in the world of data science, where systems have the ability to listen to general conversations, analyze it and make patterns. The follow can go and maybe train on YouTube videos. You can train on textbooks and so on. For instance, if you go on AI and maybe you have an exams, whatever exams you have, and you use AI, it gives you the possibility to write that exams, right? Why? Because they have studied and they're able to provide answers to your questions. You ask a question, the system knows exactly what can be, and they give you answers. Or you train your model to be able to respond. I and the team here, we wanted to build an AI model, which I think is just because we are busy with so many other things that we're working on a system to also make learning easy and novel, around us. We wanted to build an AI model that enables the ability to, if you're a lawyer who is OHADA based, you have a case, you can come and present your case to the AI, and it gives you an argument on how you can go about that case based on OHADA law. So before you go to argue in court, you argue out with the AI. The AI tells you this is how you go. They ask like this is how you present your facts this way, and so on. The AI can also try to give you the law attempts too broad, you don't know. So they listen to the case and give weaknesses of the case and give strength of the case, right? And tell that this is how you should code this particular law, justify this by this, justify this by this. I think we are still planning to build that model. But the idea was to build a model that will help in OHADA law. Whenever you have a case, whether a business case or whatever, arbitration or whatsoever, you take your case, present it right out the case very well, and put in the system. The system studies the case very well, studies it and give you what? Assumes that the case, you give two versions. Assume that I'm the defending counsel. How should I argue my case? Assume that I'm the prosecuting. How should I argue this case? What are the chances that you can win this case if you are this and you are this? And how can you put your argument? What are the sections in the law to back the argument? So I think we'll still, but maybe by the time we're done here, you guys can go and build a model. It's possible, right? So just to tell you the possibilities that are there in the world of today. It's easier to do a lot today. One of the things that I basically tell people that knowledge has been democratized. The knowledge that Steve Jobs used, Bill Gates, and Elon Musk, that they use or they're using is available to us today. The only little thing we may find it challenging, we may not have the same access to physical technologies or equipment that they have. But when it comes to the raw knowledge, we have the knowledge that we can even build as. It's just that we tend not to have support from maybe our institutions, the government, and the rest to be able to but we have access to all the knowledge. It is easier to be a programmer today and without any basic programming knowledge. And you still have build systems easily. I'm telling you what I'm experiencing. It's not something I'm talking from space on daily basis. Yes. And you can build standard applications today. All of that is because we have the knowledge available around us. It's just for us to put some little extra effort to get it. So once you collect your data, if your data is more quantitative or structured, you need to do what we call data cleaning. Again, it's not about data cleaning is whether structured or unstructured. But for this scenario, we're talking about data cleaning, which has to do with one, you need to remove duplicates. I've already mentioned that, right? A good example is you record a transaction twice. It's the same transaction. So you must remove one, right? Detect and remove outliers. Now, outliers are in statistics, these are scores of scores that significantly deviate from the rest. For instance, we go into a class and everybody scores between 8 to 12 or 8 to 14. And we say, okay, but there's somebody with 20 on 20, right? Or look at outliers as those we normally consider as abnormal in the society or around us in any situation. People are playing and you are the best. You seem to play more than everybody, right? You're an outlier. Your behavior deviates from the rest. So when you have such in your data, you need to either remove them or treat them. Because if you don't treat outliers, you will end up with results that are not that very good. Then another thing that we need to see, now these things are concepts that we are trying to get them, but data analysis is something that is practical. Yes. You may remove it, right? There are different ways to treat. For instance, you may decide to replace that particular value with a different value. We'll see how that is done. Or even if you analyze with it, you know that it affects your results. For instance, a simple example, let's assume that the government wanted to improve the standard of living and calculates and discovered that the average salary in Cameroon, right? That the average Cameroonian lives on a salary of 700,000. Is it possible? Yes. Data may show that everybody is living on a salary of 700,000. Why is it? Because ministers and they also calculate their salaries. A minister is taking around 5 million per month. But generally, you get to the real people, discover that they're taking around how much? Maybe 100,000, 150, 200,000, 250. So the average around 200,000. But because we have 10 ministers or 36 ministers who we also consider them, they made it seem as if everybody's living on a salary of what? 800,000. So the results might be good, but doesn't give us a true picture of what is. If we really wanted to understand this, the situation of an average person, then we need to either remove the ministers and give or treat them in a different way, right? Yes, so that is how it works. Because they are outliers, they don't behave like any other, like the rest of the people. Standardize. We also have to standardize and capitalize. Yes, this is a situation. It's very common. I will see it when we get to data cleaning. For instance, you want to collect data from, you go to collect data, retrieve data from a database that people are recording. Let's say go to BIECA, sorry, just using it as a name of an institution, BIECA University Health Center, and you go to the health unit and want to retrieve health data. And so the way the data is inputted in the software is that when somebody comes, they need to take the person's age, the person's gender, the patient's this and that. And so what they discovered that some people, because of time, they just, instead of writing female, they just put F, some put FE, right? Some write female with capital letters, some write with small letters, some write. Now, in data analysis, you need to treat that information before you can analyze. Because if you analyze it, the software system is highly likely to treat them as different categories. But whether it is FE or F or F in small letters or capital letters or blend, they are referring to the same thing. So you need to regularize it to either be everything should be F or everything should be, and so you have to treat that. In some cases, we have a blend of capital letters, small letters, and so you have to also know. Now, another scenario is that you have to convert data types. You may collect data, you want to do trend analysis. For you to do trend analysis, you need date, because date is a core element. But your data was inputted and you did not put it in the right format. So you need to convert the data maybe into dates. You can convert it to months. If you want to analyze data that you collected, you can want to see the behavior over months, you need to convert it to months. You may want to see over years, you convert to years, days, weeks, weekdays, weekends, and the rest. Those are all possibilities. And so you need to be able to rectify such scenarios. Then formatting, we'll see that fixed errors, maybe language translation like in Cameroon. I happen to have worked with one data set. It was from health center, a health data set. I think I still have the data set here. And they're collecting data in different hospitals. The francophone sections, they input their data in French and Anglophone, but all the data goes in the same database. So you need to translate into the same language. Then handling missing data. What happens if somebody did not give his or her age and you need it? How do you treat that? That's what we call missing data. So these are practical things we'll see, but we're just opening up to what it takes. And like we said, this is introduction and the concepts that we'll see. And so you need to know that you start talking about duplicates, outliers, missing data, and so on and so forth. Irrelevant data may seem as just, but then they are very, very critical and important in the world of data. And in some, data cleaning, we can put it garbage in, garbage out. Computer is good at that. Garbage in, garbage out. If you take your data, you take your food and you cook without cleaning it, you have the consequences of what? Food that was not clean. And so you have to do proper cleaning. It is one important step in the world of data analysis. Again, data preparation steps, data decratization, data integration, data reduction, data transformation, data cleaning. Those are different steps explaining almost what we have been discussing. We have to take our data, integrate it. We have to transform it. I mentioned what the aspect of transforming. Integration could be that you are dealing with data from different sources. You can mesh, you join, or use the word join. You will see they will talk about left join, right join, full join, inner join, outer join. That's why we'll get to Power BI. Those things, they mean different things and they apply in the world of data. So any question? That's discretization. Yes. An answer. It's asking what is data discretization. For those online. Nobody. Do we know of discrete data? Have you heard of discrete data? Mm. Heard of continuous data? Mm. We know of continuous data. So normally when you collect data, we'll talk about data types and data levels of measurement. It's a concept that when we do that, you will be able to understand data discretization. But what happens is that when you collect data, the data comes in one of four ways. Can be nominal, can be ordinal, can be interval or ratio. Now, we can further classify that data into two categories, which is continuous data and categorical data. Categorical data simply refers to data that we group each item under a specific group or a category. For instance, when we say gender, we can either say female or male. So this is a category. And so from the word categorical. We say levels of education, you can either say maybe secondary, this and that. Those are categories. But we say years of studying or distance, you discover that you may not be able to classify it easily, right? Because you can measure it in terms of kilometers, this and that. So those data types that are categorized, we call them categorical data, which means they have infinite categories. Opposite to categorical data is continuous data. So data discretization could here means that you take data that is continuous and you break it down into categories. So I can take years. I collected years of people visiting the hospital, and I come now because I want to analyze the study, analyze the data. I decide to group the people CS into the children, teenagers, young adults, the old, and maybe the elderly in that order. So how do I do that? I break in terms of years. I know as 0 to 10 or 0 to 11 consider as children, 12 to 19 teenagers, maybe 19 to 25 the young adults, then 25 to 40 the adults, late adults from 40 to 50, then the elderly from maybe 65 and the rest. So it was a continuous variable, but I break it down now into a categorical variable. That's data discretization. It clear? Okay. So we analyze data to do what? Discover patterns, spot anomalies, and we test hypotheses. Principally, we want to discover patterns. Patterns, as the name goes, anything that repeats itself over and over, right? Somebody studies your life, the person will identify certain things that keep happening. Let's say happening to you. You get it? Yeah, so you call them patterns. This particular thing keeps happening. There are patterns, they repeat themselves. Anomalies are things that may happen only once, not repeat itself, or maybe less frequent. So the essence why you are doing your analysis is to determine patterns so you can know the next when the next one will be available, and to identify things that are not part of the usual anomalies or abnormalities. Most of it anomalies, right? And so you verify your hypothesis. Hypothesis, we'll talk about hypothesis testing, which gives the data scientist the ability to draw inference with respect to what you have studied out of your sample. Now, descriptive statistics, as we'll see, summarizes your data, the sample that you have collected. But inferential statistics test hypothesis and generalize with a data set, entire data set, or entire population. For instance, you come to Boya, you sample maybe 200 students from UB. If you are dealing with UB students and you sample 200, that's what the sample. But we need to talk about the entire University of Boya student population will be different. You study and observe something that affects the students of University of Boya from the 200 and test a hypothesis whether this thing that you have seen here will replicate itself or will happen the same for the entire 200. That's the concept of hypothesis testing. That what I've noticed here can be generalized as something that will keep happening. That will happen if I leave this 200 students and go and pick another 200 students. I will let's say have the same results. If you could have the same result, it means it's a pattern. So you generalize based on that. Then data analysis goes with a lot of visualization, plotting. You have to plot all sorts of charts. We'll see them. We'll see that exploratory data analysis has to do with you collect data to gain domain knowledge, and then confirm the data types. We measure. We'll talk about descriptive statistics that talk about measures of dispersion, measures of central tendency as we make progress. We'll talk about skewness and the ability to visualize. This slide is enough for us to teach. Only this slide has a lot for us to. There's a lot of content, so many things that can be said with respect to this slide. We talk about measures of central tendency, talk about measures of dispersion, we talk about skewness and courtesy, which are elements of exploratory data analysis. So, any challenge so far? Are you tired? Talking too much. Let's discuss now. Any question based on what we are seeing? No, this theory. It's not good to our talk. So, another key concept, after we have discussed what is data, we have talked about the difference between data and information. We saw the different components of a data science or data science. We talk about the interdisciplinary nature of data science, cutting from computer sciences, statistics, maths and statistics. We also went on to see the aspects of data cleaning, data preparation, from problem definition to data collection to data cleaning to data exploration and or wrangling to analysis to model features engineering to model building, model evaluation and deployment. we established that as a data scientist, those are the core steps that you can take or you need to know. All what we are teaching or will be teaching or we will cover will fall in one of those core categories. And we explain as a data science life cycle. It starts from problem identification, and then data collection, data analysis, and the rest. And you need to know that each of these phases come with some peculiar things that you are expected to know or some tools that are useful. For instance, in data collection, you need to be able to know how to collect data from different sources. You need to be able to develop instruments, your own instruments, like questionnaires, interview guides. You need to be able to, so those are some skills that you need. You should be able to deploy these instruments, for instance, maybe on using tools like Kobo Collect, SurveyMonkey. There's another one, I think Quacktext, what we have Google Forms, which are all available to assist. And so you need to know those tools. We say you need to be able to understand how to get data also from a database, which we'll see how to collect data. You're ability to select. We mostly talk about select, maybe data from a database that meets certain conditions. For instance, you want to go to a database at University of Buea, and you are interested in getting the GPAs of students of level 400. So when you get to University of Buea, they will give you access to the database, and you need to select just the students you want. You have to use the select function, select maybe level 400 students from the department of this or from the whole university with GPA, you do specification. So that is the aspect of data collection. I collect from database. We talk about data cleaning. We can do data cleaning using Excel. We can use Power Query, which we'll see. And we can also clean using Pandas, which is a Python library. We'll see that. And once you are done with cleaning, you can do data visualization. You can use Excel, you can use SPSS, visual analysis. SPSS, you can use Python, libraries, you can use R, and what have you. Then once you're done with cleaning and you're done with analysis, you can build a model using different skill sets. Again, each area, what are some skill sets and tools that you need to. And that's what we're trying to see. Or what we'll be covering fall in one of these categories. For instance, when we get to machine learning, it's about model building, right? It's about model building. We go to deployment, communication, or reporting, building a CAP project. At the end of the day, you should be able to build a CAP project, a capstone, which is basically putting all your skills into practice. What you have learned, you should be able to come up with a project that you can present and say, I collected data from so, and analyze the data, clean the data uses, and that analyze, this is what we found. And so, and maybe build a small AI model. That is what it takes. So with that said, I think it will be very, very useful to get these skills. The skills they're diverse, they're many, but they're all relevant, right? And I just want to encourage us. This is an important step we are taking. This field, again, at times I don't want to sound as if you can search online, you can do your research more and more. I believe you have done some research, right? But this is one of the most promising fields, except that AI is trying to take away jobs from everybody, right? But this skill opens up a world of possibilities. And those who may not have such skills, either they're purely manual, right? Yes, on things that may not be automated. But if you're in a company, an organization, and you have data analysis skill, and you are good in what you are doing, then you will not likely be among the senior stars. It's because this is a senior skill. It's an advanced skill also, right? Yes. Why is because decision making, you influence decision making. You cannot be, if they want to take decision, they depend on you, on whatever you are telling them. You are not telling them as you are telling that this is what data is saying. Again, you must allow data to speak. And so the ability to allow data to speak is also very, very important, so that it should not be as if you are the one, if something happens, they should not hold you responsible. Right. Yes. So it's a high profile skill for data analysts or data scientists, especially. You provide useful information for decision making within the organization. And so if you have the skill, it will be very, very, very useful for you, those you are working with. Again, at some point it will get tough. Now we're talking, still looking very sweet, right? But it gets tough at some points. But you must also know that you have to go through that difficult moment to get right. Yes, there are some new things you have to learn. Some will be very difficult, some will be complex. But then, one of the things we try to do is not make the learning that difficult. It may be difficult, but we try as much as possible to make the exercises simple, to make the understanding as easy as we can. But then, it's a bit of science, and science has terminologies, science has procedures that we must grab them. So that's just my encouragement for you guys. And let's see what we can achieve in the next 4 to 6 months, right? So I would like us to end here. Then we will come and continue on Wednesday, 4 p.m. to 6, and thereafter we'll be able to. Yes, AI will take over. AI is threatening. Somebody else, can AI take over the job? Yes, AI is taking over the jobs. I think during the orientation, I explained the scenario where we interviewed 2 programmers and we ended up did not hire even one because we had to subscribe for an AI tool to help us in doing the job. Yesterday, I also subscribed for a new AI tool I just discovered. So instead of floating around with so many staffs, many organizations are trying to use these tools to improve. That's why if the world continues the way it's going, there will be need for universal basic income. Otherwise, there'll be extremely rich few persons, and the rest of the world will be struggling. And those who are taking the lead will be the ones. Yes. A company will be able to deliver. We may experience something like deflation. Deflation when prices keep falling, right? Yes. And that what only Apple could do, even somebody in Cameroon now can do to an extent. And the skill, that's why I say knowledge has been made available for everybody. So we are working on, which is one of our core products, is an accounting software. And we are trying to compete with, it's based on HADA. But our objective as a company is to ensure that that software is used across Africa, much more in other countries. But then beneath that is that people should uninstall the current software they're using, like QuickBooks and the rest, QuickBooks Search and the rest, and install that software. So with that, you need to build top-notch, right? For an American company, for someone to uninstall a software because install US, it must really be good. And it's much more possible today than 2-3 years ago. And so there is that competition that is thing. So AI will threaten, again, most of the people that may face a challenge with AI First are the knowledge-based workers. Knowledge-based workers. If you are not top-notch, you may not have a job if you are knowledge-based. For instance, go to University of Buea. How many accountants do they need? They may not need up to 3 accountants or 2. But for some of us who went there to University of Buea in those days when it was still very manual, they will have like 20 accountants they're not able to do, but today you pay everything online. It syncs to a database. You just need 1 or 2 accountants to go and verify and data analysts to analyze them. So they don't need all the 20 accountants needed before. That's it might not only be AI, but it's digitalization. Digitalization. Robots are coming up. Robots cook. Robots take care of children. Robots do this and thing. They are almost getting, like I said, AI is getting better and better and better. So they will, in 10 years, we'll have more robots than human beings. Some people will even marry robots. So it's very, very important for us to update your skills, update your knowledge, and be current. Be current. So you don't go and spend time learning something that might not be useful again. You need to be current. In terms of tools that you're using, in terms of where the trend is moving. Yes. So that at the end of the day, you can at least be better than the rest. So guys, I think we will end the class here for today. If there's no question again, I think we are happy that you've joined this cohort. I believe that by the grace of God, the next 4 months, next 4 to 6 months, you learn a skill that will transform your life and bring you through. If you start taking a 6-figure income, don't forget me, please. Right? So it's possible. Yes. So any question for those online, offline, any question? Okay, if there's no question, please try to regularize your financial situation with administration so that we know that you're official student and we match fire. A course outline for the different things that we treated will be issued out for those who are official students. So that's it. We end here for today and bless the see us on Thursday, Wednesday, 4 p.m. both online and offline.
So the software that you say we need to download.